Today's lesson is lesson 3.6, write linear equations. What will we learn today? To write equations in point-slope form, and to write equations in slope-intercept form. You can write an equation of a line in slope-intercept form when you know the slope and the y-intercept. Reminder that slope-intercept form is y is equal to mx plus b, where the m is the slope and b is the y-intercept. You can write an equation of a line in point-slope form when you are given the slope and the coordinates of a point on a line that is not the y-intercept. Okay, so in words, this linear equation y minus y1 is equal to m times x minus x1 is written in the point-slope form where x1 and y1 is a given point on a non-vertical line and m is the slope of the line. So pretty much we know our m is our slope. The y1 is the point that's given to us. Okay. So that's our point, or our y coordinate of the point that's given to us. And then the x1 is the x value, excuse me, of the x that's given to us. Let's look at example number 1. Write an equation in point-slope form for the line that passes through -2 and 3 with a slope of 4. So their one is to write an equation in point-slope form. So that's going to be y minus y1 is equal to m times, in parentheses, x minus x1. Okay. So the slope is given to us. M is equal to 4. And they give us my y1 and my x1. So this is going to be my x1. This will be my y1. So let me write that over here. My x1 is -2. And my y1 is equal to 3. So let's plug those in. So I'm going to plug in -3, or the y minus 3 is equal to my slope, 4, times x minus -2. Remember, when we have a negative, let's put it in parentheses. So we're going to have parentheses inside of parentheses. Let's start off by a negative times a negative becomes positive, so that's going to become positive. So we end up with y minus 3 is equal to 4 times x plus 2. And now this equation is written in point-slope form with our slope and our y1 and x1. Example 2. Write the slope-intercept form of the equation from example 1. As you recall from our last lesson, slope-intercept form is y is equal to mx plus b. Our example 1 answer was y minus 3 is equal to 4 times x plus 2 in parentheses. So in order to write this into slope-intercept form, we're going to first have to get rid of the parentheses. And we do that by doing the distributive property. Remember to always start off with parentheses. We got to get rid of those right away. So my y minus 3 is going to stay the same, equal to 4 times x, which is 4x. And then we're going to take 4 times positive 2, which is positive 8. It's still not in slope-intercept form, so I'm going to isolate for the y. So isolate the y. And the y will be isolated by adding 3 to both sides. That eliminates the -3, so I'm left with y is equal to 4x plus 8 plus 3, which is 11. Let's confirm that this is in slope-intercept form. I have y, I have my mx, and I have my b. So y equals 4x plus 11 is the slope-intercept form of the answer in example 1. Here is a list of 5 different ways to write a linear equation. So if I have a slope and a point, that's what we learned today. You substitute the slope m and the coordinates of the point in y minus y1 equal mx, or m times x minus x1. This is called point slope form. That's what we learned in this lesson. From slope and y-intercept, substitute the slope m and y-intercept b in y equals mx plus b. Slope-intercept form. From a graph, find the y-intercept b and slope m from the graph, then substitute the slope and the y-intercept in y equals mx plus b. Once again, the slope-intercept form. I'll abbreviate it this time. From 2 points, if you're given 2 points, use the coordinates of the points to find the slope. Substitute the slope and coordinates of one of those points in y minus y1 is equal to m times x minus x1. This is what we're going to be looking at next, using coordinates of 2 points to find the slope. That's using our slope formula. And then using the point slope formula, or point slope form. From a table, use the coordinates of the 2 points to find the slope, then substitute the slope and coordinates of the tone of the points in of 1, this should be of 1 of the points in y minus y1 equals mx minus 1. And we'll go over that in the next screen. Example 3. Write an equation in point slope form. Let me write that up here. Y minus y1 is equal to m times x minus x1. And slope-intercept form, let's write that also. Y equals mx plus b. For the line that passes through 8, 1 and negative 2, 9. Okay. So for both of these equations, we need to know the slope. And in order to find the slope, we are going to use the slope formula. Now we start with the slope formula because what that's going to give me is it's going to give me the m for both equations. And that obviously that's very important. Knowing the slope is actually going to help us to figure out what the point slope form is and then what the slope intercept form is. So let me take my slope formula, which is y2 minus y1 over x2 minus x1. So y2 is 9 minus y1, which is 1. Let's continue simplifying that. 9 minus 1 is 8. Let's look at our x's. Negative 2 minus 8. Negative 2 minus 8 is negative 10. And we would like to simplify this. We can divide both numerator and denominator by 2. We end up with negative 4/5 as our slope. So now, knowing that information and knowing our first point, we can take our point slope form and we are going to write y minus, and I'm going to use y1, which is 1, is equal to, I'm going to use my slope, negative 4/5 times x minus x1, which is 8. So now it's in point slope form. You put a box around that. Now that just satisfies the first, the first portion of this problem. The second portion tells us to write it in slope-intercept form. Well, I know what my m is. I know it's negative 4/5, but I don't know what my b is. And in order to find my b, I'm going to simplify my point slope form. I'm going to move that over. Let me write slope-intercept form here first. And so I'm going to take y minus 1 is equal to negative 4/5 times x minus 8. And to write into slope-intercept form, I'm going to, just like I showed you in the previous examples, multiply using the distributive property. So the y minus 1 stays the same. Let's bring that down. I have negative 4/5 times x, which is negative 4/5 times x. And then I have negative 4/5 times negative 8. Let me write that out here. Negative 4/5 times negative 8. Okay. So I always try to cross cancel, but unfortunately for this problem, I can't cross cancel. So it's basically going to be, this right here will be 4 times negative 8, which is negative 32. Well, actually, it's negative 4 times negative 8. So that's going to be positive 32 over 5. So now I have y minus 1 is equal to negative 4/5 x plus 32/5. I'm going to, I still need to isolate the y over here, so I'm going to add 1 to both sides. So I have, sorry, I forgot to add the 1. So I have y is equal to negative 4/5 x, and I have 1/32, or plus 1 32/5. 32/5 can be simplified. It can be simplified over here to 6 2/5. So take 6 2/5 plus 1. This will actually be y is equal to negative 4/5 x plus 7 2/5. So it all starts, boys and girls, with the slope formula, because all we have are 2 points. Those 2 points we can use to find the slope formula. Once we find the slope formula, so that's our first step, then we move to our point slope form. Once we have our point slope form, we can move to our slope intercept form. And now we have both answers that are required, which are the point slope form and the slope intercept form for the line that passes through 8, 1 and negative 2, 9. And we can check this by graphing both of these lines. Example number 4 is a real-world example. The cost of assistance dog training sessions is shown in the table. So we're going to refer to this table right over here on the right. Write an equation in point slope form to represent the cost y, so our cost is going to be y, of attending X dog training sessions. So number of training sessions will be X. So let's start off with we're writing down our point slope form. And as you recall, y minus y1 is equal to m. M represents our slope. X minus x1. Okay. So we need to get our slope, or find out what our slope is. Based on the information given, we can do what we learned in lesson 1, which is to find the rate of change. My rate of change for the number of sessions goes from 5 to 10 plus 5. From $165 to $290 plus $125. So we're going to take y over x to find my slope, and that's going to be 125 over 5. Now this is a real world problem, so we can go ahead and simplify this. I know I mentioned before, don't simplify it, but in this case, it's going to end up giving us the cost per training session. You don't pay $125 over 5 sessions. What you're going to do, you have to simplify that, and that actually simplifies to $25. So $25 is my slope, or 25. So let's replace m with 25. That's the cost per each training session. But they want us to write this in point slope form. So I'm going to take y minus, put my equal signs there. My y1, I can choose either one of these points. I can make this my y1 or this one. I always go with the first one listed, so I'm going to go 165. That's the first one listed. Equals, let's take x minus x1. So if I use 165 as my y1, then x or 5 has to be my x1. So we can either write it this way. Y minus 165 is equal to 25 times x minus 5. That's in point slope form. That serves the requirement of writing this equation in point slope form. So it can either be written this way, or I can write it as y minus 290 is equal to, my slope is still the same. That doesn't change. What changes is my y1 and my x1. X minus 10. Either one of these equations would be correct. Again, point slope form, y minus y1 equals m times x minus x1. We're trying to find our slope. I guess technically you could use a slope formula on this one also, but it would be much easier to find the slope using my rate of change, or finding my constant rate of change like we did in lesson 1.